Here's a function called classic Fibonacci. And what you do is you pass a limit to it, and it will compute all the Fibonacci numbers up to that limit. Notice we have a list called nums, and it does all the work, fills this list up, and when it's finally done, it gives you all the numbers. Well, what if you want the first million Fibonacci? What if you need the first 5 million Fibonacci numbers? How long will this method take to run? What if you don't know how many you need? What if you want to start looking at them and you say, well, I'm looking for the time when I'm going through the Fibonacci numbers and the second one is a prime number, the third one is the cube of the first one in the sequence. And who knows when that is? You're just looking through and you're going to decide, oh, now it matches. Now I've got enough of these. What if you were looking through this and you said, I'm going to ask for 5 million Fibonacci numbers, and it was really the 5 million and first, right? Maybe you just gave up. So we're going to look at a different way to write exactly the same code that doesn't have these limitations, allows the consumers to process as much of this actually infinite series as it needs, and yet does this in a very much on-demand, high-performance way. This concept is called generators, and it has this keyword called yield. So let's look at this in code. So here's that same function. We can run it. Shows you the first few numbers in the Fibonacci sequence. We're passing a limit here. Let's scroll down to where we're calling it. We're passing 100. So we want just the first set of Fibonacci numbers less than 100. So this is fine, but let's see if we can do better. Well, before we move on, let's actually debug this a little bit. So I'm going to put a breakpoint here. I'm going to step into this. All right, so here we are, and let's step into this method. And now we're stepping along, and notice we're going through the list. You can see up here it actually shows you the list being built. It shows you the numbers. So PyCharm is really cool in that sense. You can see the list growing. But notice we're the whole time staying here until we get to the limit of 100, which happens pretty soon here, right now. And then we're going through them and processing. You can see m is the various values here. So that's fine for small numbers. But what, like I said in the beginning, what if we don't know what the upper bound is? Or what if we have to put a really huge number here? What do you think happens to the memory consumption as that number grows? Obviously, we have to gather all the numbers that preceded it and hold them in memory all at once, and then you get the answer. So Python has this really cool keyword called yield. And let's come down here and let's call this a generator Fibonacci. So we're going to do a few things that if you've seen this before, you'll know it's pretty straightforward. If you've not seen this, it'll probably blow your mind. All right, so what we're going to do is we're going to say, instead of having this limit, we would like to work on the infinite series. Now, if I just run this code, two things will happen. First of all, it's going to crash in a hurry. Even if for some reason it wouldn't crash, if we had like infinite memory, it will still never return, right? It's just going to keep adding this infinite series, but of course, it's going to run out of memory. So in Python, we can do something which is both cleaner and better here. So what we can do is we can use this yield keyword, and yield is like return, but instead of returning from the method, it just says, hey, I want to create a collection or a sequence, and here's one of the items, and here's one of the items. So we'll yield current. So that's cool. So this is going to actually continue to yield the items. You might wonder, well, how do we ever get a value out of it? So let's go find out. So we're going to do this. Now, if I run this, it won't crash or anything. It'll just keep spitting out numbers, scrolling to the right until it kind of goes crazy. So this is an infinite sequence. But as a consumer of the infinite sequence, I can decide, okay, I've had enough. So what I'll say here is, let's say if m is greater than 100, we can use the same test as we have on line 36. We can just break out of our loop. All right, so let's run these. We should see the same output. We do, right? Classic and generator have the same output. But if we go into the debugger here, it's going to be all sorts of different. All right, so we step in. Here we are in generator Fibonacci, just like we were before. And here's our while true. Now watch what happens as soon as we get to current, which is 1. And we say yield. Immediately we're back here. We printed it. And now look where we return into the loop. We just kind of resume the method. Back here, see there's this back and forth. I'll do this a few times. Notice now we're going to jump back into this one, and that current is 3 and next is 5. This is like a state machine that remembers where it left off and can be resumed. But even though it's an infinite sequence, we don't generate all of them. It's more like on demand. As you pull items out of it, it will compute them. So only as much as you pull do you have to pay in terms of computation. The other really cool benefit is nowhere are we adding this to a list. So nowhere are we using, basically nowhere are we storing more than one item in memory at a time. So memory is not a problem in this situation. So these generators are really, really cool, and all you have to do is use the yield keyword. And if you compare it against classic Fibonacci, not only is it better performance, more flexible, generates all the numbers and so on, it's actually shorter, and once you get your mind around yield, it's actually easier to understand. So that's cool. We can also take down here, we can create something like an even generator, and if I were to pass some kind of set here, some kind of number generator like this, I could say for n in numbers, if n mod 2 equals 0, our standard even test, we will say yield n. Okay, so given any set of numbers, whether this is a list or a generator, doesn't matter, doesn't care, it's going to pull the even ones out. And then down here, I could define a method called even Fibonacci, and we'll say something like this: for n in even generator, and then we can give it generator Fibonacci, and we can say yield from this. So this will let us compose these things, so we can actually create pipelines from one to the next. So let's run our even Fibonacci through here, and we should get only the even numbers that are also coming from the Fibonacci set. And remember, this is an infinite sequence because we're starting out with the innermost bit, an infinite sequence, which itself is a generator that will take as many items as are there and pass them back. But because we don't actually do the work on this part until we pull on it, and we don't do the work on this part until we pull on it, it goes something like this. Pull here, so that means go pull on this, which pulls on this, which will pull on this piece, one item at a time. And then when we decide down here we're done, we'll break out. So look at this, we have the even Fibonacci numbers, and there's not many. So 2, 8, and 144. There they are. Brilliant. If you want more, we can get more. Want it up to 10,000? No problem. There they are, 10,000. Want it up to 1,000,000? There they are, up to 1,000,000. Boom, like that. All right, so let's look at this in a graphic. Remember, we already talked about our algorithm. Here, it's a perfect implementation of Fibonacci, but it has the limitations where you have to say how many you want before you actually get a chance to look at the numbers, and you can't look at too many or you run out of memory. If for some reason you had infinite memory, you'd run out of time. We can switch to a simpler version using the yield keyword, create this as a generator, and it actually does no work until you start pulling on the generator. Moreover, we saw that you can write multiple generators and compose them in a pipeline style, which is really awesome, especially in things like data science. Thanks for watching. This video is just one of over 50 Pythonic techniques you'll learn in my full course. Check it out at talkpython.fm/Pythonic.